I'm David Arpin, and right now I work on the SageMaker team. My background is actually in managing data science teams prior to being in AWS. I was with Amazon.com and the Fulfillment by Amazon, leading a team there. And then I've kind of worked at a couple of beer companies, so if you want to talk beer after the show, let me know. And I've worked at some loyalty card analytics manufacturers and a variety of other little places here and there. But today we'll talk about AWS and SageMaker. We'll kind of give you an overview, do the presentation thing. We'll pause and have some Q&A. I kind of threw out if you guys feel like there's a big gap or something's missing, that we could go into more depth in a certain area. Feel free to let me know. I want you guys to get as much out of this as possible. And so, if you guys are having trouble catching something, or if I glossed over something too fast, do let me know, but we'll also have Q&A breaks kind of slotted throughout, so we can kind of recap and summarize what we've learned in the last section and go into deeper pockets there. We'll do a break after that and have a little setup. If you guys want to follow along with the activities, you're more than welcome to. Otherwise, we have the examples are all coming off S3, so if you want to just download them yourself and follow along, without actually running anything on your own, that's fine too. So kind of flexible there. After that, we'll walk through each of the examples. We've got 3 different examples. The first one will be using our built-in algorithms. We're going to use blazing text, which is one of our algorithms to do word-to-vec embeddings. So that's kind of a natural language processing task. After that, we're going to do an introduction to SageMaker and TensorFlow. And we're going to use automatic model tuning, which is the service that we launched that allows you to search the hyperparameter value space to try and get better fitting models without you having to kind of invest a lot of manual effort. And then the next step that we'll go into, we'll kind of go deeper with each subsequent example. Will be an example that uses fast AI's structured data. For those of you guys who are familiar with fast AI or who aren't familiar with fast AI, it's a massively open, it's a MOOC, it's an online course that a lot of people use to get introduced to deep learning. Jeremy Howard's doing some really great stuff. It also comes with a library that sits on top of PyTorch and tries to make it very easy to do cutting edge deep learning without necessarily having a lot of mathematical background or experience in the topic. And so his tagline is making neural nets uncool again. So we're going to take one of their examples and show how you would do that in SageMaker, which includes bringing your own container and trying to take advantage of some of the SageMaker platform through that means. And then we'll do kind of a wrap up in QA. Like I said, we'll probably stop for Q&A in between each of these. And then hopefully at the end, we'll leave a little bit of time for kind of open exploration, so that if you guys want to try doing something on your problem and come up and talk to me about kind of a one-on-one topic, we can do that. Unfortunately, my assistants today had to cancel, so they weren't able to make it. So it's just me, but I'll try and spread myself as thin as possible to get to everybody's questions. So, great. So to start off, let's talk a little bit about where we see SageMaker relative to the rest of the AWS machine learning stack. When we think of machine learning in AWS, we think of kind of a 3-layered stack here, with application services at the top. These are things you might be familiar with. These are things like recognition, Lex, Poly, transcribe, translate, comprehend. So their main goal is to go very deep in a specific domain area and provide pre-trained models so that all you have to do is bring your data and use a very simple API interface to get back machine learning predictions. And so it's the easiest way to integrate machine learning into your application if you need something within that domain. And that's actually where, when you need something outside of that domain, so if you don't need a computer vision task or you don't need a natural language processing task, or it just falls into an area that one of those doesn't specialize in, you would go down to the platform services. And that's the layer that Amazon SageMaker is in. And this is designed to be a platform to allow you to build whatever you need in order to implement machine learning into your applications and daily projects. Right? We have a few other platforms as well in that layer, so things like Deep Lens, Amazon Machine Learning, Spark and EMR, and then Mechanical Turk, which is a service that a lot of machine learning people use to label unlabeled data, right? So if you have a bunch of images and you need them classified into certain buckets, and you need kind of the human eye to do that because you don't have any training data yet, that's a good way to get it. And then the last layer that both of the application services and the platform sit on top of is really our frameworks and hardware. And so when we think about infrastructure, when we think about providing GPU instance, CPU instances, Internet of Things, having a variety of different compute options for you to train and host your models on, that's where that layer comes in. And then we want to be the best place at AWS to run all deep learning frameworks. So we invest in MXNet, we contribute back to Apache MXNet, we like that project, but we also have a team focused on TensorFlow and trying to make TensorFlow run as optimally as possible in AWS's cloud. Same thing with PyTorch. We have people focused on PyTorch and trying to innovate in PyTorch and make sure that the experience customers have with PyTorch when they come to AWS is the best it can possibly be. We see a lot of different customers who are either not tied to one framework, using multiple at the same time, still kind of open-ended, not sure. It's a fast-moving space. There's a lot of stuff happening here. And so it's important for us to be able to support that breadth of deep learning frameworks. And so that's kind of how we think about the machine learning world and where SageMaker fits in. Yeah, I can. I think they'll be available on O'Reilly's website, but I'll make sure, if not, that they're shared in another means. So, Amazon SageMaker, as we think about it, has really three main components. So these three components are actually independent of one another, but well integrated. So you don't have to use all three of the components if you don't want to. You can pick and choose one, two, or three, any combination of those that you want. And you can still get a lot of functionality out of it. We think it works best when you use them all together, but there again, it's about providing customers choices and freedom. So this build, train, and deploy are kind of the three main components, and then on top of that, we've layered algorithms, so our own customized, custom-developed, built-in algorithms, deep learning framework containers, and so these are things like PyTorch and TensorFlow and MXNet containers that are ready to go and accept your code, but use within the SageMaker platform. We'll go into more depth on each of these later, obviously. And then you always have the capability of bringing your own container through Docker. So you can always bring your own algorithm into SageMaker and use it for training and hosting, as long as it can be bundled into a Docker container. It can be made to work with the SageMaker platform. And then automatic model tuning. That was I mentioned that before. One of the examples we go through will have that. But basically, the concept there is to make it as easy as possible to set the right hyperparameter values to give you the best fitting model. So if we think about each of those in a little bit more detail, in that build section, the user experience that we wanted for SageMaker was one that was ultimately very flexible. A lot of data scientists are really familiar with Jupyter Notebooks. Just by show of hands, how many people use Jupyter Notebooks in the room here? Okay, so quite a few of you guys kind of understand and know what that is, but it sounds like some also are new to it. Jupyter Notebooks is a great way to sort of interactively run code, write documentation, visualize data in a very kind of exploratory, natural fashion, kind of an IDE for data scientists or an interactive development environment. And so SageMaker's notebook instances are the easiest way by far to get spun up with an instance that is running your own Jupyter Notebook server that just kind of works and integrates with the rest of your functionality within AWS. But you don't have to use SageMaker's notebook instances in order to benefit from the other two components. Like I said, it's a pick and choose, whatever options work for you. So you can actually use Apache Spark. So we have a SageMaker Spark SDK. This allows you to naturally integrate the other SageMaker components of training and deploying into your Spark workflows without you having to think about how am I going to get my data frame from Spark into SageMaker. right? And so we try to make that very easy for you. There's obviously a console experience if you need to kind of point and click to either manage your resources or to kick off training jobs and manage the rest of the functionality. And then you can always bring your own device, right? So you can use an EC2 node, you can use your laptop, whatever works best for you. So the train component is next. So the goal here was to really make it zero setup and give you a managed and distributed training environment of your own. So you create a training job with Amazon SageMaker. We go and provision instances for you. We load your algorithm code from a Docker container. We load data in from S3 to those training instances. We train the model. We take the model artifacts out and we send them back to S3 and then tear down the cluster without you having to think about anything. All of that's kind of set up for you and pre-baked and managed. So it becomes a very effective way to quickly and easily spin up either a large number of jobs, recurring jobs, jobs that require very customized, highly specialized processing. And it's all sort of zero setup from a very easy API interface to use. We support streaming data sets and distributed compute, so you can pick your data up from S3 and land it on the training instances, or you can stream it right to your algorithm. And so we have a methodology that we call pipe mode to do that. There's also, distributed compute is very easy. Spinning up a job with one instance versus 10 instances is as easy as changing one argument in a function call. So very easy to kind of scale with the size of your data, as you can either stream it in or process across multiple nodes. Everything is based on Docker, and that integrates naturally with ECS and ECR. So I talked about algorithms and frameworks and the bring your own container option. All those three things are just Docker containers, and they're different flavors and variants of how we use Docker to publish that. So it's a standard most people are used to using already, is how SageMaker works. And then once you train your model, this goes back to the independence of the components. The model artifacts are yours, and you can either deploy those to a SageMaker endpoint, or you can deploy them to a DeepLens device, or you can deploy them with Greengrass. You can kind of take them and do whatever you kind of want with them. So going into the deploy section. The deploy is really meant to be one step and very easy as well. So once you've trained your model, and again, you can train in SageMaker or train outside of SageMaker, we really wanted to make it easy for you to deploy to a real-time production hosted endpoint that's going to be auto-scalable. It's going to be highly available. So if you have multiple instances, they'll be spread across availability zones. And it's going to be highly reliable with a lot of other functionality as well. So you can do A/B testing. So A/B testing, you can deploy multiple models behind the same endpoint and control what percentage of traffic goes to each model. We have blue-green deployments everywhere throughout. So if you're training an old model and then you want to update that with a new version of your model, but you don't want to put 100% of traffic behind that new version of your model because you just want to make sure it's tested first, you can do that. You can deploy a second variant of your model with an A/B test and send 5% of the traffic there, make sure it's functioning as you expect it to in the real world, and then scale up so that it gets 100% of the traffic as you're scaling the other version down, and all of that without having any endpoint downtime because we do use blue-green deployments. Right? And again, you have the flexibility to train outside of SageMaker and host within SageMaker. We also have batch. So if you have real-time prediction needs that you want a website constantly being able to do an HTTP post request, pinging that endpoint and getting back a prediction, that was the previous use case. If you say, hey, every day I have to predict for 100,000 products what sales are going to be the next day, but I only have to do it once, and it all happens within a 5-minute period. You can do that with batch transform. So SageMaker has a batch transform functionality that, again, zero setup, very easy to use. We stream data right off of S3 into the batch transform instances and then back to S3 without you having to think about that. We can distribute across multiple CPU or GPU instances. So there again, it's typically inference of machine learning is trivially parallelizable, so we can scale up very large and very easily that way. And again, you can bring your own model with this functionality. So talking about the algorithms in a little bit more detail, we have kind of an eclectic mix of algorithms. Some of the algorithms are things people are going to be used to, things like XGBoost and linear regression and classification. And some of them are going to be a little bit more unique. So we have a forecasting algorithm that we call DeepAR, which is all about time series forecasting. It's actually an algorithm Amazon.com developed internally in-house and now has made available through SageMaker. We also have some deep learning algorithms that a couple of years ago people weren't using at scale in a large way. There's kind of a relegated small community of people who were able to train object detection models and do things like sequence to sequence for neural machine translation. And so we have algorithms that are in those spaces as well, and just kind of a variety of different options. And we'll go into each of these in a little bit more depth. So when we think about the frameworks, the main goal here was this. We know customers are trying to develop their own algorithms and build their own neural networks within these deep learning frameworks, TensorFlow, PyTorch, Chainer, MXNet. And so what we've done is we've pre-built containers for each of those deep learning frameworks. And then the goal is you can prototype your code as you normally would, write it like you kind of do in your Jupyter Notebook or your EC2 instance, whatever works best for you. And then very quickly and easily test it locally, run it at scale in SageMaker, and then deploy it to a production service, right? So you can start with this small sample of data, use SageMaker scale to scale up from a training perspective, and then use its ability to deploy in real time means as well to integrate it right into your application and make it very easy and kind of low friction for data scientists and machine learning researchers to get engaged. Finally, the bring your own option. If there's a certain framework that we don't support, whether that's Scikit or whether that's R or Caffe, Java, anything that can be sort of bundled into a Docker container. Like I said, you can add that algorithm code into the Docker container, publish that to an ECR repository in ECS, and then use it within SageMaker as well, and still take advantage of things like managed training infrastructure and auto-scalable hosting and all the other nice features that we've added to make those things easy. It's called DeepAR, D-E-P-A-R. Yep. And so there's a published paper, academic paper about it that's written by some of the folks in Amazon.com. If you're interested in learning more, I can either get you a link, or I'm sure Google will come up with it faster than I could. And then finally, SageMaker automatic model tuning. We'll have an example that'll show how to use this, but the general concept of it is have a tuning job which orchestrates a much larger number of training jobs and searches the hyperparameter space to give you an improved overall fit in your model. And we have a special customized in-house developed algorithm to do this. We use a combination of Bayesian optimization and Gaussian processes to actually say, based on initial training runs, we build a meta model that says which hyperparameter values are most likely to correlate well with good model fits. And so that's how our mechanism works, is that we run a couple of training jobs and then we predict where good hyperparameters will be. We do a combination of exploring that hyperparameter space, and then once we find good hyperparameter values that we like, we exploit and we search much more within a dense region to really try and optimize the value that you're getting out of it. So going into the algorithms in a little bit more detail here. If we think about the supervised learning algorithms, we have linear learner, which is basically linear regression and classification in the same algorithm. You can see that we've really engineered and built these algorithms in many cases to be advancements in both science and in engineering, right? So our linear learner algorithm isn't the same as a open source version that you would get kind of off the shelf. They function differently typically from a methodological standpoint. And so there's both kind of science advancements in that, as well as engineering advancements. They've been engineered to not have to read the entire data set into memory, to use streaming paradigms. They've been engineered to be able to work in a distributed fashion, so they can share state across a large number of training instances. They've been engineered to take advantage of GPU acceleration when it exists. So in a lot of cases, these algorithms have been kind of engineered from the ground up with both different methodologies and with different engineering practices to be very, very fast. And so you can see here we've got accuracy on a variety of different tasks here, where SageMaker, is achieving pretty much the same accuracy or better in almost all cases, and then also doing it in a much faster way, which turns into a much cheaper cost for you as the end user, because it's less billable time that we're actually running these instances. Sorry. That's other. Okay. In this case, other is Spark, but we've so most of the Spark ML algorithms, right? It varies a little bit from algorithm to algorithm if Spark doesn't have one of them, but yeah. We also have boosted decision trees. So this is one of the few algorithms where we actually just took the open source package and bundled it up into a container and made it work in distributed fashion, and then said, okay, we're done. Part of that's because XGBoost is already really fast. Part of it is because people are so used to that algorithm and how it works, and are so comfortable with it already. And so XGBoost, the real advantage here is just the fact that it can scale up to, we've got tests here up to 67 machines, C4 8x larges, right? So that's just a huge amount of data, a huge job, and still get good scalable results in terms of how fast you're training models and things like that. So having that capability of running XGBoost on the largest of problems is what kind of SageMaker affords here. Factorization machines is another supervised learning algorithm that we have. So factorization machines is kind of an extension of a linear model where they use pairwise interactions of features but represent them in a reduced dimensional space. So with factorization machines, it's very popular for things like recommender systems, very popular for things like click prediction and ad targeting. And we've got one of the faster, more scalable methods. We essentially have linear scalability where when you go from 10 machines to 50 machines, it's the exact same cost because we get it done in 1/5 the time, right? So it's a really powerful implementation on, in this case, over 1 terabyte of data. K-nearest neighbors. So this was one of the algorithms that we've launched relatively recently. The nice thing about SageMaker's K-nearest neighbors is we support dimensionality reduction for pre-processing. So if you have a very large feature space, K-nearest neighbors can have a lot of problems with inference time, right? So it takes a long time to generate a prediction because every time you're generating a prediction, you're actually going back and doing the search again, right? You have to search for the neighbors. When you do dimensionality reduction as a pre-processing step, you're reducing that computational time and shortening your time for inference. We use Facebook Vice for indexing to further speed things up and then allow for subsampling as well. So all those things give you a lot of bells and whistles to tune and get, in the end, very, very fast inference latencies, even though that's usually the most computationally intensive part about nearest neighbors. And again, it can take advantage with Vice through GPU acceleration, things like that. The next one is deep AR forecasting. So I had mentioned this before. So this is an algorithm that I mentioned we developed in-house. It's used to predict a large number of interrelated time series. So most forecasting algorithms take one time series at a time and predict it. So if you think of ARIMA and Holt-Winters and the even basic LSTMs, most of them are just designed to handle one time series at a time. Deep AR is a recurrent neural network-based forecasting algorithm, but it's designed to use the strength in numbers to generate better predictions on each thing, especially when it comes to cold starts. So you have a new cross-sectional unit that comes into your time series panel data. You want to make a prediction for it. If it's similar to something that already exists in your data set, you can do a better job of prediction. So you can see different examples of where you might use that, right? So traffic on different roads over time, electricity demand by each individual household, page views across a bunch of websites, server traffic across a bunch of instances in in a shared cluster, right? So you can do all these things where you're predicting these time series that are interrelated with one another, and by leveraging the similarity between them, you can get a lot better results. Amazon actually, if you read the paper that you can find on Google, Amazon talks about how they use it for their product forecasting. So we have obviously the world's biggest selection, and when you think about that, it becomes a real inventory challenge to try and forecast all the different products, especially with all the new products coming in. And so we find deep AR comes in a lot of help when you think about, I've got a new pair of Nike shoes. Well, it probably sells more similar to existing Nike shoes than this HDMI cable. And so we can use that kind of strength to fit these large time series models, these time series panel models with deep AR. In the unsupervised learning space, we have things like k-means, so very kind of standard popular algorithm. But again, where we've tried to add value is the scalability and the speed. So you can see we're over 10 times faster than alternative open source offerings. And that in a lot of cases we scale to either larger data sets from a feature dimensional perspective or from a number of row perspective. Principal components, blindingly fast. You can barely even make out the line in the lower left-hand corner there, but just almost linear scalability and throughput again. It's designed to scale to the largest data sets and still be fast. Random cut forest, so this is an anomaly detection algorithm. It's designed by doing a bunch of random splits on your data and then looking at elements that come to the top. As the earlier you split that item out, the more likely it is to be an anomaly or an outlier. This algorithm has been available in Kinesis for a while, and people use it on a lot of streams of data. So streams of server logs and things like that. We want to make it available in SageMaker as well so that people could take advantage of it even outside of the streaming context for anomaly detection. Computer vision, so I mentioned we have an image classification algorithm that's implemented in MXNet, and it uses ResNet. And you can control the number of layers and a variety of other hyperparameters, obviously. You can also do transfer learning with it. So you can start with a model that's been pre-trained on ImageNet, and then start from that and fine-tune your last layers of weights, or retrain your last layers of weights, and still get a really good fitting model, even if you don't have a lot of data that you personally have labeled. Object detection, which we recently launched, so that's SSD, single-shot multi-box detector. Again, has a ResNet, or you can have a VGG network underneath. And we've kind of hit that kind of state-of-the-art performance that you kind of see published in academic research with our implementation. For the natural language processing side of things, spectral LDA, which is just a blindingly fast implementation of latent Dirichlet allocation. This is a topic modeling algorithm that's designed to take large corpuses of text, look for words that are frequently occurring or frequently occurring within a specific genre of text, and then work out which topics are discussed within this large corpus of text, break it apart into kind of a soft clustering of what's going on within the text. And so spectral LDA is a very fast implementation of that. And then we also have neural topic model, which is a similar model in terms of they both do topic modeling. This one uses a neural architecture and can really scale up to a really, really large number of topics. Sometimes that's hard to interpret a large number of topics, but you can do it if you need to use it as like a pre-processing function on your data in order to split it into smaller groups. And this methodology in particular provides really good accuracies relative to other kind of topic modeling algorithms, even as that number of topics gets large. Sequence modeling. So this is based on Sakai. Sakai is an open source package that Amazon released for neural machine translation. This sequence algorithm can be used for neural machine translation, obviously. It can also be used for other things. So document summarization is one use case that people also use sequence to sequence for. Here again, can support kind of multi-GPU training, and you can use RNN or CNN as the encoder-decoder framework. So very flexible implementation there. Blazing text, so this is word-to-vec algorithm. Word-to-vec is an interesting algorithm where you essentially generate word embeddings. So each word in the text that you pass it gets a numeric representation, and words that mean something similar to one another are going to appear close in that numeric feature space, and words that are very different from one another are going to be farther apart. And they're also going to have some unusual relationships. So one of the common ones that people talk about when they talk about word-to-vec is something like king, the numeric representation for king minus the numeric representation for man, plus the numeric representation for woman equals approximately the numeric representation for queen, right? So you're getting these really rich relationships across these words in word-to-vec. So let's pause there, stop there, and I'm going to take some time for questions. Yeah. Yep. Yeah, definitely. When we do the examples, I think you'll see we have a few different ways, right? So Amazon has that kind of classic API structure, which is not very scikit-learn-like. And so what we've actually done is created this thing called the SageMaker Python SDK. And basically, it wraps the rest of the APIs into a more scikit sort of experience. So when you call one of our algorithms, you're training in the cloud and you're kicking off this distributed managed hardware, so you have to specify some extra arguments like, how much hardware am I going to use and what Docker image am I going to point to? But you can also just do a dot fit and point to data into S3. So now instead of like grabbing a NumPy array in memory, you're going to point to the data in S3, and it's going to kick things off for you. And that dot fit, predict functionality is very kind of we tried to kind of align it to that sort of scikit opinionation. And so we think most data scientists are going to feel a little bit at home while using it. Yeah, online learning is an interesting topic. Online learning in SageMaker really depends kind of on the cadence that you need to retrain at. So if you need to retrain at an unspecified interval in very, very tiny mini batches, SageMaker is probably, we don't have functionality right now to make that easy. If you want to train every day, once a day, if you take a, yeah, if you take, so if you, yep. Exactly, yeah. So if you want to do that on a daily basis, then it's just about orchestrating the rest and relying on the rest of the functionality that AWS offers, right? So things like Lambda functions to pick up new data when it lands in S3, retrain your model, pick up the new model, deploy in that kind of that A/B testing. Hey, maybe I'm going to start with 1% of the traffic, and then move up to 10% of the traffic, and then move to 100% of the traffic. It's really just about kind of leveraging the strength of what's already there, I think, in AWS to take advantage of things like Lambdas and things like that. Yeah. A marketplace for predictors. Can you tell me a little bit more about what you're interested in? Yep. Interesting. We don't currently have that functionality, but that's a very interesting idea. Yeah. Yeah, the question was, sorry, a marketplace of predictors in the sense of if one company wanted to train a model to do something very well and then offer that for sale to a bunch of other companies, could they do that? And it is a very interesting idea, but it's something we don't currently have the functionality for. Other questions? You guys either really want to get to the examples or I answered all your questions already. Kind of surprising. Okay. So let's do this. Let's start moving to the examples. And again, feel free to kind of stop, reach out as we go along. Let me know if something's moving too fast or isn't clear. And then we can kind of detour if necessary. Okay? Let's do, I had a break planned, or I mentioned a break after the Q&A, but let's do this first. Let's go through and create a notebook instance. Let's have everybody do that. I've got some instructions here. Let me talk you through those. We'll go through and we'll create a notebook instance, and then I'm going to hand out AWS credits for everybody. It's a little unusual as to how to do this, but when you go on break, leave your laptop or something there to let me know you're there, and I'll just drop a credit slip on your thing, and so that way you get $30 and you get to do this without having to worry about, is my finance partner going to be mad at me that I spun up 75 GPU instances for a training. Just kidding, it won't actually be 75 GPU instances. We'll keep it pretty light. So even if you don't use the credit, your finance partner won't be too mad. So we'll do that. So we'll do redeeming credits after you guys come back from the break. For right now, let's create a new SageMaker notebook instance. So you can do this a few different ways. If you want to create one instance and do everything on that notebook instance, you can just spin up a GPU instance like an MLP3 2x large or an MLP 2x large. If you want the actual SageMaker experience, where very often people have small notebook instances that orchestrate these very large training clusters, pardon me, you may decide to use an M4X large too, right? So I'll leave that kind of up to you. One of the examples does require GPU computing, but you can always spin a second one up later if you want. It's really your flexibility. Let's try and organize by last name just so that we don't run into any unusual usage spikes or anything like that. So if your last name it starts with an A through I, use Oregon. If use the Oregon region. If your last name starts from J to R, use Virginia, and S to Z, use Ohio. And then, so maybe I'll break at this point in time, and we'll start doing this together. Okay? So I'll actually go ahead and walk you guys through what that looks like. And then, like I said, I'll send you guys on break. I'll bring around the credits. And if you don't have a chance to follow along while I'm doing this now, you can always do it when you get back. I'll put the instructions back up. Is that big enough for everyone to see? You and the folks in the back? Yep, cool. Thank you. Okay, so we'll start out at our AWS console. Still logged in, good. And well, you probably won't have SageMaker as a recently visited site, so let's scroll down to where we find it. So in machine learning, click on Amazon SageMaker. And I'll just stay in Northern Virginia. We can click on notebook instances, create a notebook instance, right? And you can call this whatever you want. Call that test. And I'll just spin up the P2. Leave the P3s for you guys. In your IAM role, something might be here if you've already used SageMaker. If you haven't used SageMaker, just create a new role. Actually, either way, you probably want to create a new role because we want to make sure we have access to any S3 bucket. And that's the only functionality we really have to change there. And then click Create Role. So I've got a new role that I just got created for me. And then you don't have to change anything with VPC, lifecycle config, or encryption key. We're not going to do anything with any secret data here. So we'll just create that notebook instance as is. Okay. So, and that'll show pending for a little while while it goes and provisions the instance. While we're doing that, let's change a few things. So click on that instance. So I clicked on just the hyperlink that was that notebook instance. Go to IAM role ARN. Yep. Do any S3 bucket. There's a radio button that says any S3 bucket. And I'm sorry, you said it's not creating?
Yeah, I just clicked on the button.
Okay. Give it a second. That'd be great. Yeah. So we've got, luckily, someone from AWS, not an official assistant, but we'll dub him one now. We'll make him one, and he can come around and help out with getting set up if you guys experience any difficulties. So we want to attach a new policy. So we clicked on our IAM role, and that took us to this Amazon SageMaker execution role that we just created. We're going to attach a policy. Repository. Oop, sorry. Search for a registry, not repository. And we want to add this top one, Amazon EC2 Container Registry Full Access. Right? So select the checkbox next to that, and then just do attach policy. Okay. Back to my notebook instances. That's still pending. I'll open up one that already exists. So when I do open it up, I'll be greeted with the familiar Jupyter Notebook dashboard. I'm going to ask all of you to go ahead and, depending on which region you're in, we're actually rolling this out this week. You may have a button up here that says Try Jupyter Lab. If you don't have that button, just delete tree and type lab in the URL. Okay, and then you will be in a Jupyter Lab setting in the notebook instance. Okay, so we'll do that. Let me confirm I caught all of our directions. Okay, so that's all the directions you need to do for now. Okay, so we'll take a break. Like a little 5, 10, what time we have? Let's just take a 7-minute break. We'll be back at 2:25, and I'll pass out the credits in the meantime, and you guys can try and get set up and let me know if you run into problems. Okay, cool.